Hey guys, and welcome back to a new video. And today we're actually going to try something completely new because we're going to build a desktop app. So no more mobile, at least for today. Don't worry, I will still make Android videos. However, today we're going to make a desktop app using Jetpack Compose. Yes, that is possible. There is a Compose desktop version, which I actually tried out and I really like it. It's really simple. And you can see we're going to build a simple stopwatch here. So we can simply click start, and then we can have a simple timer. We can pause it, we can resume it. We can of course reset it and start it all over again. So that is what we're going to build. That's a desktop app that will run on Mac, that will run on Windows, because it is in the end a JVM based app. So it runs on pretty much all operating systems, which is pretty cool. And all you need for that is IntelliJ. So IntelliJ, for those who don't know it, is basically the IDE we use to write Java code, to write Kotlin code that's not related to Android, and some more things. But we will of course use Kotlin code here today. So you can just download IntelliJ, Google for IntelliJ download the community edition, you're fine with that. And then inside of IntelliJ, we want to create a new project. And it's super simple. We just go to File, New, or for you probably a dialog will pop up where you click on New Project, and we select Project here. Then this will show up. You can see you have a bunch of options. You can also make an Android app here, which I don't recommend, because for that we have Android Studio. You can do tons of cool things with IntelliJ. We're going to choose Kotlin here, of course, and the name will be Stopwatch. Stopwatch Compose Desktop maybe. Then here we need to choose a product template. We scroll down and you can see we have a Compose desktop application. And we simply select that. You can see we can even use Compose to make a web application. If you want that, then put it in the comments and maybe I'll also take a look at that in future. And of course, multi-platform here, which I also already took a look in regards to KMM, Kotlin Multi-Platform Mobile. I already have a video about that. Then we're actually good to go. We want to have the Kotlin Gradle build system. Project JDK is fine. And we can simply click next here. Then the template will be Compose desktop module. For the target JVM version, I'll pick 11, even though I think we could choose higher versions here. But from Android, I'm used to this one. Let's click Finish. I want to open it in this window. Yes, please terminate this. And there we go. We have an empty Compose desktop project. It's really that simple. It's just like creating an Android app. Let's actually take a look here what we have in this root structure. We of course have a build.gradle file, which just contains here, you can see a Compose plugin. Yeah, it's very similar to Android actually. We have a Compose desktop block here to basically configure that, but we don't need to worry about all that because this IntelliJ IDE here already did that for us. However, if we take a look here in source, main, Kotlin, and main KT, then you can see that is now our desktop app. We have an app composable and we have a main function here. So that's of course called when we launch our program. And yeah, that's how we simply do this here in Compose Desktop. We really don't need to worry about this for now. We won't touch this main function. But you can see it already contains some code. We can run this here by clicking on this play symbol. And there we go. We have our very simple sample app with a button Hello World. And when we click on it, it says Hello Desktop. Very cool. Let's jump back to IntelliJ and actually start to write our stopwatch. Before that, one thing, if you actually want to use the Compose preview, then you want to open your settings and go to plugins. And you want to make sure that you have this plugin installed, this Compose Multi-Platform IDE support. This will actually come with the support for the preview annotation. So if we actually use the preview here, then we get this little Compose button. If we click it, then we will see the preview here, and it's actually a lot faster as for Android apps. And we can also quickly refresh the preview. In my case, if I actually hit Command B or Control B, for example, if I change the text here to just hello, Control B, then you can see it directly changed it. It of course needs to rebuild, but it's pretty fast if you just make small changes. If you don't have this shortcut, again, open your settings, open the key map, and here search for refresh. Scroll down, and here you get a refresh or run preview action, key map action basically, and you can double click on that to add a keyboard shortcut, and also use Ctrl B or whatever you like for that. However, we are not going to need this stuff here, so we can remove the text, we can remove the button and just leave our theme here. And what we're now going to do is we are going to write our stopwatch. For that, I will write a little helper class in our Kotlin package here, right-click new Kotlin class of file called stopwatch, and press enter. There we go, let's make a little bit of space. And inside of this class, we will just, first of all, create some variables. On the one hand, we want to have some compose state. So it's basically the same as we know from Android. We're going to have state, and when that state changes, our UI will in the end update. So we really don't need to learn any new concepts, at least in regards to building the UI and changing it. So let's actually have a variable here for a state, which I will use the formatted time for, by mutable state of, and here we are going to choose 00:00:000 as the default value. We want to import this, and then we can actually create more here. We're going to need a coroutine scope, private var coroutine scope. Well, because here for desktop, we of course don't have a lot of things that have a life cycle like we have in Android. So we don't have a real view model with a view model scope. So we can just create a coroutine scope here that's by itself bound to the lifetime of the application, but we're also going to cancel it, of course, if we cancel our timer. So this will just be used in the end to run the timer, to have a loop in which we delay this for a few milliseconds and then just update the corresponding time. So we can create this here using coroutine scope and using the main dispatcher. Then we want to have a Boolean actually, whether this stopwatch is active or not. By default, it's inactive, so it's not running. We're then going to have a private var for the time millis. So basically the time of our stopwatch in milliseconds, which we'll then use to simply format that to a string in this format and forward it to our UI by simply updating that state. And our UI will then detect that and change accordingly. And we actually want to have something called a last timestamp, which is also equal to 0L by default. That's just something we're going to use to calculate the difference between the last time we actually updated our time and the current time. And then we can actually already start to write our start function. This should of course now start tracking time and start running the stopwatch. So first of all, I want to check if the stopwatch is actually already active, because if so, we simply want to return and we don't want to start it again. And if not, we want to simply launch a new coroutine here in our coroutine scope. So coroutine scope.launch, just the same as in Android, we have access to the whole Kotlin framework and all of its dependencies, and of course also to Java dependencies, just the same as on Android, but now we're actually building a desktop app. So first of all, we want to set the last timestamp here to the current timestamp we get from the system. So system current time millis gives us just the current time in milliseconds. And if we start our stopwatch, we of course also want to set it to active. So we want to say this at stopwatch is active is true. Why do we do this at stopwatch and not just is active? Well, you're going to see this can lead to an issue. Not in this case, but yeah, it's a little bit confusing because this coroutine scope also has a variable which is called isActive here. You can see it from the coroutine scope, which just checks if the coroutine is active. And we just want to make sure we really refer to our isActive Boolean here. So we simply prepend this at stopwatch. So we refer to this is active here. And then we can simply launch a while loop here. As long as this stopwatch is active, we actually want to now update the time. Let's first of all delay it by, let's say, 10 milliseconds, because that's how often we want to update it. So each 10 milliseconds, we want to have a change in our UI. And then we can simply say, okay, we use our time millis and we add a new value on top of that, for which we're going to use the new time minus our last timestamp. So that will just give us the time difference between the last time we tracked and now, basically, which will, yeah, be roughly 10 milliseconds here. But that's just a little bit more accurate here if we directly calculate that using the actual milliseconds. And after that, we want to make sure that we actually update the last timestamp with the system current time millis again. So it actually considers that new last timestamp, you can say, in the next iteration. And we actually also want to update our state here, of course. So we now want to format the actual time. And for that, I will create a separate function, because single responsibility principle, a function should only do a single thing. And if we start this, then it should really only be worrying about starting and running the stopwatch and not about formatting time. So we actually create a private function here, format time, that will give that will take the time in millis, and then give us a string that's just formatted here. So first of all, you want to take this time millis and construct a local date time object out of that, which we can simply do by using local date time. And let me actually make the preview a little bit smaller. Local date time dot off instant, because that way we can get that off epoch milli. So we just construct this local date time object using our time millis. And yeah, it takes another value, which is a zone ID. Here we can just choose zone ID system default to just refer to the default. Next up, we want to have a formatter, which will then take this local date time object, which we now parsed, and actually parse that to our actual string with the pattern we want. So that will be a date time formatter of pattern. And now we need to specify the pattern we want to use here, and that is SS: and triple capital S actually. So that will make sure that's the minutes, seconds, and milliseconds. And we can actually also make sure that we refer to the locale.get default. So having these two values, we can then return local date time dot format, and here we can simply then pass our formatter. So far, so good. Now let's use this function here in our while loop and say, okay, our formatted time state is now equal to format time using our new time millis to update that. Then we're now only missing a pause function and a reset function, which are both very simple. So let's have a function pause. Here we just say is active to false, which will then also lead to getting out of this while loop. So that's really everything we need to do for pausing this. And function reset, in which we're going to reset all these values we have here to their corresponding default values. So first of all, we want to take our scope and cancel it. And if we actually cancel a coroutine scope, or all coroutines in a scope, then we also need to actually reassign it if we want to reuse it. Otherwise, it won't work. So if we would launch a normal coroutine here, that wouldn't launch if we canceled it before. So let's just assign a new coroutine scope here. Coroutine scope with dispatchers main again. We're going to reset our time millis to 0L, our last timestamp to 0L, and our formatted time to the default time. And of course, is active to false. And that's pretty much it for our stopwatch class now, which we can then use to actually build our UI and actually show these formatted time values here in our timer in the UI. So let's actually next go to our Kotlin package and create a new Kotlin class of file. And we're now going to build our UI in Compose. So that will be called stopwatch display. And we simply annotate this with composable, just like an Android, stopwatch display. And well, which values will that composable take? It will of course take the formatted time here in form of a string. It will take an on start click lambda to just propagate up that event, on pause click, and on reset click. And let's also make sure that we pass a modifier, just like usually in for most composables here. And then we can write our compose code here. So how will we do this? If we take a look here, then it's a very simple UI. We just have a column here. The first row of that column is actually taking a text here for our stopwatch. And then we have a row inside of that column with our 3 corresponding buttons. Let's write that. So we have a column. This one, we want to make sure that we attach a modifier, actually the modifier we pass here, and want to make sure that we center the content. So the vertical arrangement is arrangement.center. Horizontal alignment is alignment.center horizontally here, and we're good to go. Inside that, as I said, we're going to have a text composable. The text is equal to our formatted time, which is now going to be updated when we run our stopwatch. Let's set the font weight to bold, the font size to 30 SP, import SP, and the color to black. Then let's add a little bit of spacing here below this text. So spacer with modifier height, 16 dp. You can see it's pretty much like an Android, which is super cool. And below the spacer, we now have our row with our 3 buttons. So row, where we actually want to attach a horizontal arrangement. So arrangement center again, we just want to center our 3 buttons. And we want to have a vertical alignment of alignment.center vertically. And then we can, and we can open this block of code here. And by the way, let's also make sure that we use a modifier here to fill the max width of our parent column. And here we're just going to have 3 buttons, super simple. So first button on click function will be on start click. And we give it a text of start. And we can add a little bit of spacing between these 3 buttons, which will be modifier width, 16 dp. And then we can copy this code and basically paste it 2 more times. And remove the last spacer here. So we just have the space in between these buttons. This button will be on pause click, replace the text with pause, and on reset click, and replace this with reset. And that's pretty much it for this simple composable. We can now jump to our main file and actually use that here in our app composable, simply using stopwatch display. Before that, we actually want to create our actual stopwatch. So simply val stopwatch by remember. So we don't want to reinitialize that every time this is recomposed here. That's why we use remember. And in here, we create our stopwatch class. We probably need to import that. No. Oh, because we don't have state here, that's just equal to remember. And then we can use our stopwatch display and pass our formatted time using our stopwatch.formatted time. We can use on start click. Here we want to use stopwatch start. So when we click that, we simply want to start our stopwatch. In on pause click, we say stopwatch pause. On reset, stopwatch reset. And yeah, that's pretty much it for our desktop app here. Let's run this. We can also run the preview here, and then we should already see what we built here. And you can see that's exactly what we want. We might actually wrap this into a box so it's centered on our screen if you want that. So that way we could simply say box. And we say content alignment is center. And we put this stuff in there. Need to also make sure that the box fills the whole screen size. So we attach a modifier fill max size. If we then import modifier on the one hand and actually rerun our preview, take a look here, then you can see that is looking pretty good. And if we now want to try this out, because this is not interactive here, we simply click on run, and there we go. Here's our stopwatch. Let's try it out. Clicking start. That feels pretty much like a stopwatch. Clicking pause. And that does not really feel like a stopwatch. Let's take a look what the issue could be. So here we definitely say we want to pause it. So the issue must be either in stopwatch display. No, we actually use on pause click here. So it must be in stopwatch. So yeah, you can see the issue is here in the while loop. This is basically an italic here, that it refers to the coroutine is active and not to our isActive boolean. So we simply need to say this at stopwatch that is active again to make sure we really refer to this is active boolean. If we then relaunch that and try this out again, clicking start, clicking pause, now we really pause our stopwatch, clicking start, then we resume it, and if we click reset, we reset it. So that's pretty cool. And if we pause it first, then we can also reset it. So yeah, we have a working desktop stopwatch here, which is actually pretty cool because we really used our typical Android Compose code for that. I think it's really easy to make this, and I didn't have any issues with creating the projects. As you just saw, it's super simple with IntelliJ, and it's not such a big pain as we have with Kotlin multi-platform mobile currently. When setting that up, that was a huge pain. But with Compose Desktop, that's actually a lot better and cleaner. Do you actually want me to make more about Compose Desktop? Did you find that cool, or do you say, no, we only want Android content? Please let me know that in the comments. Would be super cool to know. And if a lot of you actually want more Compose Desktop content, then yeah, I will of course do that. Don't worry, I will always also make Android videos. But yeah, I think everything that uses Kotlin is cool. So let's start a little discussion in the comments and see how many people actually like Compose Desktop here. Thanks again for watching the video, and see you back in the next one. Have an amazing day. Bye bye.